Welcome back to Mathematic 59 YouTube channel. This is my question that somebody had a question on from section 4.7. This is about what to do when you have a car going 118 miles an hour. Actually, it's kilometers per hour. We're not in America anymore. We're in Canada. And there's an accident 55 meters ahead and slams on the brakes. So next thing you know, the velocity goes down to 0. Now, I don't know how long the time is. But I do, and I don't even know, well, we know the distance is 55. What you're going to realize upon further review is that the distance is represented by the area under that velocity. In effect, we have to find the area of a triangle in order to determine how long he needs to slam on the brakes. And then after we determine that time, then we have to determine the deceleration situation. So, well, if you watch WebAssign, they'll probably tell you that acceleration is some constant value. Actually, acceleration is the derivative of velocity. So since this situation has a linear function for velocity, you could just call this the slope of the velocity equation. Yeah. Which means that the velocity would be some equation in the form mt plus the y-intercept, which actually is given to be 100. Well, right now it's 118 kilometers per hour, but you're going to find out there's also some problems with that. So all I know is that if I could get a situation where I could figure out the slope of this line, given the other information, we're going to be in great shape. And I don't think we're going to really need a whole lot of calculus other than this relationship. Now, of course, if the velocity were quadratic or something else, we'd be in trouble. But in this case, velocity is just going to be a straight, linear, decreasing function. So let's take that. And we do know that the distance is the area under that. So what I'm going to end up doing is, in order to find t, I'm going to revert back to the area of a triangle. So 55 meters is is 1/2 of t. Now here's the situation. I have 118 kilometers per hour. But the problem is I need to have things in meters. So I have to go and convert the kilometers to meters. I also have to convert the hours to seconds because time's going to be in seconds. So I have to go ahead and also do the h equals 3.6 times 10 to the third seconds. All right, so I'm using scientific notation a little bit. And remember, if I talk too fast, you can always watch this slower. Yeah, of course. All I know is that this is going to simplify down to 55 meters equals 59 over 3.6 meters per second. Yeah. Times t. So I'm going to go ahead and I'm going to solve this algebraically. I'll get 55 times 3.6 over 59 meters. Or yeah, that's going to be T. And when I do the division, I just know the meters are going to cancel out and I'm going to be left with seconds. So that's going to be my expression for seconds. Now, of course, most of you will not be happy with a fraction like that. So you probably might want to get an approximation. It ended up being 0.3356. Wait, I did it wrong. Never mind. You know what I did? I forgot to, it's 55 times 3.6 divided by 59. 3.35. Okay, yeah, I forgot to do something. So 3.356 seconds. Okay, yeah, this is going to take a lot of data. So all I know is that this is 3.356. Now, when I take the acceleration situation, here's the problem I'm going to have to deal with. I have to deal with the fact that I had to convert kilometers per hour to meters per second, which means when I find the slope, see the acceleration now, I'm sure you've taken good notes on all of that. I just know that the acceleration is now the change in position over the change in time. I know the change in time is 3.356. The top turned out to be that conversion factor 118 times 1,000 over 3,600. Yeah, this is just getting too complicated for me. It's a complex fraction, but I'll just liken it down to decimals. I ended up getting 118 times 10 divided by 36, which is 32.778. And then I have to divide by 3.356. So once I did that, the answer turned out to be 9.766, which turned out to be 9.77, which is the correct answer. That is the acceleration in meters per second squared. The reason why you have per second squared is because you have a situation on top, which is meters per second, and you're dividing by seconds. See, this is meters per second, and then this is second. So that's where you're going to get your second squared, and that's why we calculate acceleration. So hopefully you enjoyed this video. Go back and recheck it time and time again, and don't lose a whole lot of sleep, because at worst, you may see one problem like this on the test. And you'll see one problem on WebAssign. And once again, credit to Stewart and Transcendental Calculus for providing this problem. May forever rest in peace and live in our hearts, James Stewart, the author. Thank you very much. Make sure to tune in for further videos.